Right. Going live. Right, okay, so we've got a series of 3 lightning talks now. We've got Chris Larkin on the prioritisation of obstruction removal of active travel networks.
Cool. Hello everyone, I'm Chris. I'm in my first year of my PhD at the Geospatial Systems CDT up in Newcastle Uni. This is actually work I did for my Masters of Research, and it's very much on the application end of free and open source geospatial data, as I'll go through. So briefly, just a bit of background on active travel networks, particularly in regards to the UK. Active travel, walking, wheeling, cycling is kind of the low carbon, health beneficial, low cost alternative to motorised transport, which is gaining quite a lot of traction. You see it in places such as the Netherlands, where it's really effective. Within the UK, we have the National Cycle Network. This is sort of the backbone of active travel within the UK. It's got over 8,000 kilometres of traffic-free paths, and it's really important for people getting around. However, there's a lot of problems with the National Cycle Network as it is at the moment. There's over 5,000 barriers, which or obstructions with a width less than 1.5 metres, which is the sort of design standard stipulated by the Department of Transport. And these barriers aren't fair to all of the users. If you're in a wheelchair, if you have a pushchair, if you have an adapted cycle, or even if you just have a normal bike, as a lot of these people demonstrate, it can be really difficult to pass through these obstructions. And for even people who can pass through the obstructions, it's a big deterrent stopping them from switching from their car to active travel. Sustrans are the custodians of the National Cycle Network, so they sort of manage the National Cycle Network, and they have an aim to get rid of all of these barriers by 2040. However, they can't do them all at once, and you need to think about where you can get the best gains quickly in order to access these benefits as fast as you can. So essentially, this project aims to determine the order of which these of the removal of these obstructions on active travel networks. So how did I actually do this? Well, conceptually, we used sort of this open source stack, I guess you'd say. So open data sources, OpenStreetMap, everyone knows, stuff from the census, and stuff from Sustrans' open data portal. All the processing for this project happened within Python, particularly using stuff like NumPy and OSM-NX, which are all network analysis tools for Python that use geospatial data. And then finally, classic, visualize it in QGIS. We identified sort of 5 key metrics that will be able to score the barriers to determine the removal order. And also 6 sub-metrics of some of these metrics to determine the score. The first metric that we considered is the transport poverty in the area that the barrier is located in. So we looked at the LSOAs with which the barrier is located in, and looked at the index of multiple deprivation, which is sort of a poverty score, and the vehicle ownership per person. This is because poorer areas are more likely to use active travel, so therefore are adversely affected by being limited to use these corridors. We also looked at the barrier width. A load of volunteers from Sustrans who collected the data set went out and measured the critical width, so the minimum width you have to be to fit through a single obstruction. As you can see, the vast majority of them are under that 1.5 meters, which the DFT wants to be larger than. So we're not doing a desperately great job there. We also looked at the distance that you gain on the National Cycle Network from removing these barriers. So that's the minimum distance gain, so as soon as you reach a new barrier, and also the overall distance gain, and particularly at junction points that can be in 4 or 5 different directions. We also created a metric to look at the accessibility gain of before and after the barriers removal. So we looked at the number of amenities that you can access within a 15-minute walk or a 15-minute cycle from a location, and then compared it to once the barrier has been removed from the network. So you can see you can get over to this side of the river once the barrier is removed, but you couldn't previously. So any amenities, hospitals, schools on the other side have now been unlocked by removing this barrier. We also borrowed some stuff from sort of graph theory to measure the number of users who are flowing through any point on the network to try and determine how important the obstruction is in regards to the number of people passing through. So the first way we did this was using between centrality, which is basically just a graph metric which tells you the importance of an edge within a network. We also created this one called edge usage, which using census data from the travel to work origin destination matrix, you can work out where people are actually traveling within a city and therefore give it a score. So for example, seeing a lot of people passing over this bridge where there are barriers on, so obviously those barriers are going to score pretty highly. Then consulted a load of stakeholders from Sustrans to keep them in the loop, and they basically scored all the metrics using an analytical hierarchy process, which is how you pair off different metrics versus each other to determine an overall score. So what did we actually find when we did this? Well, for a start, the stakeholders really liked the barrier width and accessibility gain metrics. They thought they were really valuable in determining the latent demand, so the demand that we don't currently have, but we might have in the future. We applied this to 2 different study areas to see how it works. So we had York and Pembrokeshire, both different in kind of spatial and demographic characteristics. And as you can see, we kind of get these clusters of high scoring barriers that need to be removed pretty quickly. We can confirm that these clusters are actually clusters by using local Moran's eye, and we can see that, yeah, those clusters are prevalent. In York, we see them on the sort of exterior to the city centre. The barriers on the city centre don't really matter because you've already made it into the city centre, but it's the ones allowing you access into the city centre that were important. In Pembrokeshire, it was the ones in the populated areas, it's kind of what you'd expect. The clusters are important because when Sustrans actually go out and remove them, they don't want to be removing barriers at kind of random locations. It makes much more sense to do it in sort of a coherent fashion. So if you identify where the clusters are, you could then remove those ones in that cluster first in order to essentially open up the network as best you can. So what have we done? Developed a new methodology using an open source stack to measure the importance of barriers on the active travel networks in an aim to basically get them removed and to enable people to travel a bit more freely. It obviously doesn't solve all of our active travel problems in the UK, but it's a small step on the way there. All my code is on GitHub if you scan the QR code, and thanks to all of these people for letting it happen.
What was the purpose of the barriers when they were originally